So we have this pool ball here, right? And then they're shooting it, and he wants to hit it to this second one that's right here. Okay, and so what I was doing, because I worked this out earlier, I just made this into a right triangle. So I don't know if you guys did that yet. But I went ahead and just drew that out so I could see one of my right triangles. Because the whole goal of these problems is just to get all of your similar triangles going on. Okay, so what I did is I drew it off to the side just because I didn't want to keep working in the pool table and just to make it a little cleaner. Okay, so I know that this guy on the bottom is a right angle. And then do we remember that every like diamond is 12.5 inches? Yeah, okay. So that's really important for us. So the bottom then, let me use this color. The bottom one has, let's see, it goes 1, 2, 3. So right, so 3, where's my calculator at? I lost it. What's 3 times 12.5? Oh yeah, 37.5. Yeah, where is my calculator? What the heck? I just had it on my desk. I'm telling you, don't get old, guys. It's terrible. Alright, so it is 37.5. Alright, so the bottom of this guy is 37.5. And then in the book, they told you that the width of the pool table was 50 inches. So I know that this guy is 50 inches. So we good so far? Okay, cool. So I want to know, like the whole point of these problems was to get these angles. So I'm going to go ahead and find this angle down here. And I just labeled it a green theta. And then this just ends up being a tangent problem. So we good so far still? Okay, so I'm going to go ahead and do tangent of theta equals, and then it's my opposite over my adjacent. And so that becomes, let's see, 50 over 37.5. And then we have to do inverse tangent of 50 over 37.5. And this would be a great time if I had a calculator. Maybe one of y'all can do it for me. Oh, cool. Perfect. 53.13 degrees. And then, let me go ahead and make that the green one. And then I also want to find out, I'll make this other one up here. Let's see, I'm trying to think of a different color. I'll do it black. So we'll also talk about that angle at the top too. And so we just have to do 90 minus 53.13. I'm really sad. I don't know where my calculator went. What the heck? I didn't hear you. Say it again. All right, 36.87 degrees. Okay, cool. So I'm going to go ahead and I'm going to just label this guy with my green theta and this guy with my black theta, just so I can see the two differences there, right? So the ball travels and it hits this top mark and then it's going to bounce off, right? And so what I want to do is I'm going to go ahead and draw another triangle, because I know that this guy is going to bounce from this top part and it's going to come and it's going to hit this side of the table somewhere. I don't know where, but it's going to hit it somewhere, right? And so that's what we want to find out, because the whole goal of this problem is to see if this ball will ever go in a pocket. Okay? We good so far still? Okay, cool. So this is my right angle down here. Okay? Now, if we have to like kind of think this through a little bit, since this guy is the black theta here, okay, I would know then that this angle here would have to be the green theta. Whoops, go away. Right? Because this is just ends up being like alternate interior angles, right? Still with me? I haven't lost you yet? Okay, cool. So since this guy here is the green theta, and this is kind of thinking about how the light hits the mirror and then it bounces off, then that means that if this is a green theta, then this guy inside will also be the green theta. So that angle there we know is 53.13. Okay? And so then that means that this guy here ends up being the black theta, and I know that that's, what was it, 36.87. Okay? Still good? Okay, so I do know this side length here, because this side length on the top is 2 of the diamonds, right? It's going over 1 and then 2. So I do know that this side length here is 25. And so I'm trying to figure out where this ball is going to hit. And so all I need to do, since I know that these guys are similar triangles, I can just set up a ratio of sides, right? A side over a side equals another side over another side. Okay? So I'm going to look at my blue triangle here. And so if I did like 50 over 37.5, so I'm going to write that off to the side, 50 over 37.5. I could make that equal to this guy, and I can go ahead and just call this side that I don't know, I can call it x, right? And so then this guy would be x over 25. And then we want to cross multiply that. Okay, and it would be a great, oh, I found it. It was on my bed. All right, so we cross multiply. So I get, let's see, 37.5x equals 50 times 25, which is 1250. Divide both sides by 37.5. And then x equals, let's see, divided by, I got 33 1/3. Do you guys agree?
Yeah.
Yeah? Okay, cool. Let me go ahead and use a different color. Because it's like 33.33333. So I'm just going to do 33 1/3. All right, so that tells me then that this length here, where this x is, it's hitting at 33 1/3. Okay? So what that's going to tell me then is this ball here, right, is going to now bounce off. Let's do another color now. Right? It's bouncing off the right side. And it's going to bounce and it's going to hit somewhere on the bottom side. Right? Again, I don't know where, but that's what we're trying to find. Each time we're trying to figure out where is the ball hitting on the new side. Okay? So I get another right triangle. And then I'm still getting all these similar triangles. So since this guy was the black theta here, I know that this angle here in this magenta one is also going to be a black theta. And then the green theta is going to be down here. So I'm just trying to keep track of all these angles. And then now I actually can find this side pretty quickly, because if the whole length is 50 and x was 33 1/3, then to find this side, I just have to do 50 minus 33 1/3. Right? Because I know the whole length's 50. I already know part of it's 33 1/3. So what does that end up being? Yeah, 16 2/3, yeah. That's kind of hard to see how I wrote it, but it's all good. 16 2/3. So then we want to do this again, where I want to find out this bottom side here. And so I can label this guy y. And I just want to figure out where is it going to hit along the bottom now. Okay? So I want to do the side ratios one more time. Okay? So I'm going to still keep the 50 over 37.5, just because that's an easy one to use. So I have 50 over 37.5 equals. And now I'm going to do it with my magenta triangle, which would be 16 2/3 over y. And then we cross multiply that. So let's see, we get 50y equals, let's see, 16 2/3. Oh, no, I can't do math today. Times 37.5. So I get 625-ish. And divide both sides by 50. And so y ends up being, oh, 12.5. We get 12.5? Cool. Okay, so that actually means I probably could like readjust my picture here, because that means that it's hitting at this first diamond, right? Because each diamond is 12.5. So since I'm using my little fancy tablet here, I get to like redraw mine real quick, just because I know now that wherever this ball was going to hit, I know that it's hitting at that first diamond now. right? Because it's at 12.5. Okay, so now our last thing is that we want to see where it's going to do the final bounce, and I'm telling you now it is going to like go into a pocket now, because it's going to take off from here, right? And it's going to start going up. Now, it's going to eventually hit the top side, right? Before it hits the left side. Does that kind of make sense? That when it's bouncing off of here, it wouldn't like just like magically like go straight and like hit the left side first. Like it's gonna have to hit the top side first. So that tells me that whatever triangle I have here, so let me go ahead and I'll pick, let's see, do I have any other colors I haven't used? Red triangle. Right, so it's like bouncing off here. Okay, and I know that it's gonna hit the top side first, right? So I know that this side here is gonna be the length of the pool table, right? And how wide was the pool table? 50, right? So I know that this side here is 50. And we already have a triangle that I drew down here, right? That had a 50 there. So that means the distance that it goes on the bottom has to be 37.5. Right? We got our same triangle that we started with. And since this means that the bottom of this red triangle that I drew, since it's 37.5, we know that that's 3 like diamond markers away, right? Because each one's 12.5. So if I start here at this first guy where my red triangle is starting, and I count 3 over, I go 1, 2, 3, and I end up on this bottom pocket. And then remember, it's going to go up 50. And so it ends up going into this top left, top center pocket. So it does go into a pocket. And you just have to, the last part kind of got me messed up too, because you have to realize that it's gonna hit the top first, right? It wouldn't just shoot and hit the left side, that it's gonna hit that top first. So if I know that this is 50, then I can find out 37.5 from our first triangle. Okay, hopefully that makes sense. All it is though, it's just similar triangles. And if you look at the work that we did here, it was a inverse tangent problem, and then it was like 2 side ratio problems, and that was it. So does that kind of clear it up? Yeah, okay. I can go ahead and like highlight and show you too, right? The ball went this way, and then it went this way, and then it bounced off, and then it went straight into that pocket. Okay, and all it is just figuring out all of those different right triangles. All right, y'all got any more questions? Nope. Good. Okay, cool.